The question says, when aqueous iron 2 chloride reacts with aqueous sodium hydroxide, solid iron 2 hydroxide is formed. And we have the reaction down here. If 133 milliliters of 0.286 molar aqueous sodium hydroxide solution is reacted with excess iron 2 chloride, what mass of iron 2 hydroxide will form? And it gives us the molar mass of iron 2 hydroxide as 89.86 grams per mole. So this is kind of a combination of the previous several questions. And essentially, we are starting with 133 milliliters of this solution, and we know that it's 0.286 molar solution. And what we're asked for is how many grams of this iron 2 hydroxide solid we can form. So this is what we're looking for. We're also told that there's excess iron 2 chloride, which means we know this is the limiting reagent and we don't have to worry about this one. We have plenty of this one that it's not going to run out, so we don't need to do any math for it. We can focus our attention on this sodium hydroxide. And in the previous question, it was a titration problem, but here we're going to have a basically a solution forming a solid, or a double displacement reaction, or a precipitation reaction specifically in this case. So let's look at what we can do. Well, if we could find the moles of sodium hydroxide, we could convert it to moles of iron 2 hydroxide using the balanced chemical equation, and then to grams of iron 2 hydroxide using the molar mass. So let me write that down. So we can convert from moles of NaOH to moles of FeOH2 using the balanced chemical equation, and then to moles, or excuse me, to grams of FeOH2 using the molar mass. But how can we find moles of NaOH? It turns out that we have a volume and a molarity. If you have both a volume and a molarity, you can find moles. So what we want to do is we want to turn this volume in liters of NaOH to moles of NaOH. Remember that molarities can be thought of as equalities. What this means is there's 0.286 moles of NaOH equal to 1 liter of this NaOH solution, because this is moles per liter, moles per 1 liter. Said another way, if I have 1 liter of this solution, it has 0.286 moles of NaOH. So these two things are equal. Keep in mind, we can't use milliliters. We have to convert this to liters, so we have to divide this by 1,000. So what we want to start with is 0.133 liters of NaOH, not 133 milliliters, otherwise we'll be off by a factor of 1,000, times. Now we want to use this equality to find moles. Well, we want liters to cancel out, so we want to put that 1 liter of NaOH on the bottom. On top, we want to put the 0.286 moles of NaOH. Then we want to convert from moles of NaOH to moles of iron 2 hydroxide. Always, 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 if you're going from moles of one thing to moles of another, you're using the balanced chemical equation. So in this case, we want NaOH to go, so we're going to put the 2 moles of NaOH on the bottom, so it cancels out, and the 1 mole, because there's a 1 there, mole of FeOH2 on the top. Now, we want to convert from moles of iron 2 hydroxide to grams. We're going to use the molar mass. In this case, this is the grams in 1 mole, so we put the 1 mole of FeOH2 on the bottom, and the 89.86 grams of FeOH2 on the top. Multiply by the top, divide by the bottom, multiply by the top, divide by the bottom, repeat to the end. And when you do this and you have 4 significant figures, you get 1.709 grams of FeOH2 that can form. It's really important to practice these solution stoichiometry problems, whether it's a titration or whether it's a precipitation reaction, because for whatever reason, they do tend to be quite challenging. To make it easier, if you will, or more familiar, practice is your best option.